First example in finding the area of a plane region. Let's find the area of the region bounded by the curve y equals x squared, the line x equals -3, and the x-axis. Let's plot the curve y equals x squared. When we substitute x values, we obtain y, and the curve is a parabola. We're also given with line x equals -3 and the x-axis. The region R is then bounded by the given quantities. We will find the area of this region. There are two solutions for this case. For solution 1, we will use vertical rectangular elements. We're dividing the region into several rectangles or subintervals. Inside this subinterval or rectangle, let's choose a number inside this subinterval, and let this be psi I. On top of this number is a point on the curve with coordinates psi I squared. The width of this rectangle is delta Ix, and the height is the point on the curve which is psi I squared, such that we can obtain the area of this ith rectangle. And to sum up the area of all n rectangles, we have this Riemann sum. The limit of this sum as norm approaches 0 gives the measure of the area of the region. And the limit of the Riemann sum is a definite integral. So the area A is calculated by integrating x squared dx from -3 to 0. The limit is from -3 to 0 because we are dividing the region into vertical rectangles. Let's have solution 2, using horizontal rectangles. From the given y equals x squared, we can obtain x equals square root of y. Now let's divide the region into horizontal rectangular elements. Now focus yourself on this single rectangle or subinterval. There are many points inside this subinterval. Let's choose psi I. Straight ahead is a point on the curve with coordinates squared psi I. The width of this rectangle is delta Iy. The height is 3 minus square root of psi I. Why? Because the length from the origin to the line x equals -3 is 3. And this point on the rectangle is x equals square root of psi I. So the area of this ith rectangle is just the change in x times the change in y. So summing up all the n rectangles, we have a Riemann sum, and the Riemann sum is a definite integral. So the area of the region is obtained by integrating the product of 3 minus square root of y and dy from 0 to 9. Why the change in limit from 0 to 9? It's because we divided the region horizontally, and since the curve and the pink line meet at y equals 9. And so the area of the region is the same when we divide it horizontally and vertically.